In this video, we'll start with the first experiment of digital circuits, that is the truth table of logic gates. So the aim of this experiment is to study and verify the truth table of logic gates. The apparatus that we'll require for this experiment is the baseboard, a couple of ICs, and a few jumper wires. So to start with this experiment, you'll first have to mount the desired IC in any one of the 10-pin sockets that are available on the board. There are 4 of them and you can use any one of them. Then using the provided pin diagram, you'll have to find the pins that connect to VCC, to ground, and the input and the output pins. The VCC pin will have to be connected to plus 5 volts and the ground pin will be connected to the ground pins. Then you can connect the input pins either to ground or to plus 5 volts, that is logic 0 or logic 1, depending on the test case that you are implementing. You can connect the output pins to the LED box or to the 7-segment display as per your choice. Then you can vary the data on the input pins and you can observe the output that is produced. On this observation, you can verify the truth table that is provided along with the diagrams. So the first gate that we have in this experiment is IC7404, that is the NOT gate. So the NOT gate is a very straightforward gate that complements the input that we give. It is a 14 pin IC with pin 7 and pin 14 dedicated to ground and VCC, and it has 6 gates within the single IC. 6 of these pins are used for input and 6 of these pins are used for output. There is only one input, that is A, and if the input is logic 0, it is complemented and we get logic 1 as the output, and if the input is logic 1, we obtain logic 0 as the output. The next gate that we have is the AND gate. It is a 2-input gate and it comes in a 14-pin IC, again with pin 7 and pin 14 dedicated to ground and VCC. The two inputs A and B are essentially multiplied to get the output. So if we have 0 and 0 as the inputs, the output will be 0. In fact, if we have 0 as any one of the inputs, the output will always be 0 since the multiplication will be 0. In only one case, that is when we have A and B both as logic 1, we'll obtain the output as logic 1. The next gate that we have is IC7432, that is the OR gate. The OR gate again is a 14-pin IC with 4 gates within it. In this gate, both the inputs are added. So if we have both inputs as logic 0, the output will be 0. But if any one of them is 1, then the output will be 1. The next gate that we have is IC7400. It is the NAND gate. So the NAND gate can be visualized as an AND gate that is connected serially with a NOT gate, since the output of the NAND gate is complemented. So over here, on observing the truth table, you can see that the input is the complement of what we get with the AND gate. So if both the inputs are 0, we get the output as 1 since they are multiplied and then complemented. This again is a 14-pin IC with pin 7 and pin 14 for ground and VCC, and there are 4 logic gates within a single IC. And finally, the last gate that we have for this experiment is the NOR gate. So the NOR gate again is an OR gate that is connected serially with a NOT gate. So in this case, you'll have to be careful because the pin layout is different as compared to the other gates. In most of the other gates, pin 1 and 2 are the input pins and pin 3 is the output pin for the first gate. But in this case, in this gate, pin 2 and 3 are the input pins and pin 1 is the output. And if both the inputs are 0, the addition will be 0 and since it's complemented, the output will be 1. Similarly, you can verify all the test cases for all the ICs. And the next part will demonstrate how to use all these ICs live on the mobile lab and how you can observe the output using the LED boxes.
Welcome back everyone. This is the second video of the mobile lab. In this video, we'll start with the first experiment of digital circuits, that is to verify and study the truth tables of logic gates. So within this kit, we get a small box which contains all the necessary ICs. So from this kit, we'll first pick the NOT gate, that is IC7404. So once you have the IC, you can mount it on any one of the free sockets that we have. All of these are 10 pin sockets and there are 4 of them on the board. So after mounting the IC on the board, you can start making the required connections.
So for making the connections, you will first have to refer the manual which will be provided. So this is IC 7404. In this, the first pin, sorry, the 14th pin is the VCC which is connected to the plus 5 volt, and the pin number 7, it is connected to the ground. So as this is the NOT gate, so the first pin is the input pin and the second pin is the output pin. So this is how a circuit looks like after making the connections, and make sure the power supply is off while making the connections. So after making connections, we can verify the truth table. So the input here given is VCC or plus 5, or we can say as logic 1. So if we turn on the board, so we can see that the output is 0. We can conclude this as the LED is not glowing. So when the input is logic 1, the output is logic 0. This is the first case of any truth table. Now if we took the second case in which the input is ground or logic 0, the output must be plus 1. So here we can see that LED is glowing now. So we can say that when the input is given as logic 0, the output is logic 1. This was the truth table of NOT gate. That's it.
So after verifying the truth table of the NOT gate, we'll move on to the AND gate, that is IC 7408. So I'll mount the IC in the same socket as before, since we already made the VCC and ground connections for it.
So after looking into the pin diagram of IC 7408, the pin number 14 is VCC or plus 5 volt. The pin number 7 again is the ground. Here we will use the different pins. So the pin number 13, pin number 11, 12, 13. These are the pins which I will use right now. So pin number 13 is input. Then pin number 12 is again input. And pin number 11 is the output. So now we will verify the truth table. So if both the inputs are 0, then for NAND gate the output again is 0. So here we can see that as LED is not glowing, we can say that the output is logic 0. When one of the input is plus 5 or logic 1 and another is the 0, then again output is again 0. So here we can say that as LED is not glowing, so we can say that the output again is 0. And when both the input are plus 1 or plus 5 volt, then the output is plus 1. So here we can see that as LED is glowing. So when both the input are plus 1, the output is again logic 1. So by this we can say that we have verified the truth table of AND gate.
So after verifying the truth table of the AND gate, we'll move on to the OR gate. So in order to remove So after verifying the truth table of the AND gate, we'll move on to the OR gate. But before removing the IC, make sure that the power supply is off.
So now let us verify the truth table of OR gate. So by referring the pin diagram, the pin number 14 is again the VCC, so we have to connect it to the plus 5 volt. The pin number 7 again is ground, and yeah, so right now we will make the connections for OR gate. So the pin number 1 and pin number 2 again is the input in the OR gate, and pin number 3 is the output. So this is how our circuit looks after making the connections. So now let us start with the last case, which is if both the input are plus 5 volt, or we can say that logic 1, then what is the output? So here we can see that if both the inputs are plus 1, then here LED is glowing. So we can say that when the input is 1, 1, then output is also 1. When any one of the input is 0, then again still LED is glowing. So we can say that again it is the logic 1. And what if both the inputs are logic 0? So let us check it. So now we can say that both the inputs are logic 0 as they are connected to the ground. The LED is not glowing. So we can say that when both the inputs are 0 0, then output is also logic 0. So that was the verification of truth table of OR gate.
So after verifying the truth table of the OR gate, we'll move on to IC 7400, that is the NAND gate. So make sure before you insert the next IC, the power supply is off.
So after inserting the NAND gate, this is how our circuit looks like. After referring to the pin diagram of IC7400 or NAND gate, you can say that the pin number 14 again is the VCC, so it is connected to the plus 5 volt. Pin number 7 again is ground. Now let us check the various states. Now let us verify the truth table of NAND gate. So this is the first case in which both the inputs are 0 0. So now let us check what is the output. So after inserting IC, this is how circuits look like. So by referring to the pin diagram, here pin number 14 is again VCC and pin number 7 is ground. Now let us verify the truth table for NAND gate. So here we can see that pin number 1 and pin number 2 are the inputs and pin number 3 is output. So here both the inputs are connected to the ground, which is logic 0. So if the inputs are logic 0 0, then output must be 1. So let us verify that. So here LED is glowing, so we can say that the output is logic 1. When the input is, when any one of the input is logic 1 and another is the logic 0, so here again LED is glowing, so we can say that it is also logic 1. Now what if both the inputs are logic 1, then what is the output? So here we can see that the LED is not glowing right now, so we can say that when both the inputs are logic 1, then the output is logic 0. That was the verification of truth table for NAND gate.
So after verifying the truth table of the NAND gate, we'll move on to the NOR gate. So now I'm going to mount the IC7402, that is the NOR gate.
So after mounting the NOR gate, which is IC7402, at first we'll look to the pin diagram. So pin number 14 and pin number 7 are again VCC and ground. But the IC7402 has quite different connections. So make sure you look into the pin diagram very carefully. So in IC7432, pin number 2 and pin number 3 is the input and pin number 1 is the output. So this is how it looked like after making the connections. Now let us verify the truth table. So when both the inputs are 1 1, then let us see what is the output. The expected output is to be is 0, which is logic 0. So now we can see that when both the inputs are logic 1, the output is logic 0 as LED is not glowing. What if any one of the input is logic 1 and another is the logic 0? So again LED is not glowing, so we can say that input when one input is logic 1 and another is logic 0, the output is logic 0. And what if both the inputs are logic 0? So we can see that LED is glowing right now. So we can say that when both the inputs are logic 0, at that time the output is logic 1. So that was the verification of the truth table for NOR gate.
So this concludes the experiment on the verification of the truth tables of logic gates. Around 5 of these logic gates were covered, that is NOT, AND, OR, NAND and NOR.